Okay,
Okay, we get more people now. Couple.
I have this, but it's recording already. When you don't, please send me an email. Okay?
It's recording already, right?
Yes, it is.
Okay. Yeah, couple more minutes. We're gonna wait if other people can join because we're starting at 11, right? Hi. 6-5.
I actually do.
Great. So I'll do 667 now in addition to 651. So good.
Well, um, so far this class is actually, I mean, it's the beginning. It's very challenging, very new. Exercise our group submitted, we didn't really get that good a grade, so we just make sure that to join just to make sure that get as much information as possible for this assignment.
Mm-hmm. So those. Okay. Okay. So that's 11 o'clock, right? We're gonna go ahead and get started. So first of all, thank you guys for joining. Can you hear me okay? Yeah. Another thing that I would like to ask you is that if you're speaking, I'm asking you to mute the mic, right? Okay. And this presentation will be recorded for your classmates who are unable to attend, right? So we'll start by reviewing the process of discretization. Right, it's a topic from last week, but I received some questions on that, so I'm going to go ahead and I'm going to start sharing stuff. So we you said, right? Only you did exercise. Look at this. The discrete version, right? This split values of attributes in intervals. So you have less values, right? And also some algorithms work only with normal values. So instead of length equal it the values into ranges. Notice some of you ask me what does mean? E stands for infinity. So in other words, first interval means the value is 168.95 or less. Well, saying between 168.95 to 177, but well, notice that in a third interval, we always have an inf, right? That means that positive infinity. It's 177.5 or more. Notice that you have a square bracket. It means that it is inclusive. Curly bracket means exclusive, right? The slope was nominal already, right? So here in the data set, we are predicting the same line and the six distinct values, right? Sim is a dependent variable. It's an attribute that we have to classify. The possible values are -3, -2, 1, 0, 1, 2, 3. So this is called a class. And the column tells you how many instances do you have that fall in each class, right? So there are possible classes, right? So now we go in here, filter. I'm gonna go choose filters, and it choose discrimination, supervised and unsupervised, right? Supervised into account the class of the dependent variable. But if we have miles per gallon as a continuous value, and I wanted to be into years, so in this case, the supervised discrimination, because my symbol, right, it's small. The supervised takes into account a class, and we not specify the number of beans to use. Right? So to share something related here, when I click on search, the candidate will attribute this click, right? So double click, right here you have a capabilities and tells you what is appropriate when it's not appropriate to use a type of discretization. Like for instance, is this binary class a nominal class of dependent variable? That's when you use the supervised. And here it tells you what types it's going to work on. Okay, binary, no, string, we're going to see that later in the course. And it means that the algorithm can handle the missing values, right? Unknown values. Dominant, yeah. You guys to please mute the microphone. I have some kind of background noise. Thank you. Now here, you attribute indices. What it is, it tells you the position of an attribute you want to discretize, right? So here is an position, here is an attribute name. Now let's see if I have that open. No, that's later said that I will open. I said I had that open. Right, so let's do that. Let's open, actually go ahead and open the one that's not, let's say, and I'm going to go ahead and I'm going to open this one. So here, this is a car data set, but the difference is that it's not discretized, right? So when it's not discretized, here is the statistics for it. So notice that you're showing the minimum value, maximum, and deviation. But you hear me okay? To ask you again, when you're not speaking, please try to mute your microphone, right? Symbol in the last attribute. It is selected for a class as a false, right? So is numeric. Statistics are different here. Gallon is also numeric. Speed is numeric, and length is numeric, right? So what I do is to predict markdown, right? If I want to use, if I classify the miles per gallon attribute, notice that this is continuous, right? So what to do is I need to discrete out into ranges. So I'm going right here and I change my class miles per gallon. Notice that it goes, so here choose to filters and I'm going to go to supervise discrimination. Notice it goes why? Because we no longer know the class of my dependent variable. We no longer know it. So you use the supervised discretization in this case. So we have another option. We can use the non-supervised. I'm gonna go ahead and we can choose. I'm gonna go and select unsupervised and I'm going to attribute and I'm going to discretize, right? So double clicking here. I'm not here. You specify attribute index. It's a position of attribute that you want to discrete. Here, number of bins, 10 is a default. So bin is basically telling me the interval on how many inputs do I want to divide the bins. Use equal frequency or if set to false, it's going to use equal width. So suppose that amount a range between 16, 15, and 54. So 54 minus 16 divided by 10, perhaps. That's going to show you how each interval is. So that this approach is sensitive to outliers. What if I have a value that's super big or super small, right? So it has outliers. This is accepted. So now I'll go ahead and let's see miles per gallon, and I'm going to set this to do and click OK. Click apply. All right. It's the attribute again. Sorry. Okay. It shows me it divided the values 5 ranges and show me the number of values, the number of instances rather that have a value each. The attribute type is nominal, and right here I see the claims for I'd like you to mute the microphone, thank you. So here,
Excuse me, Yelena? Ask Susie Tucker to mute her phone because I think she's interfering with the audio. It's kind of choppy and I can barely hear you.
You can hear me?
You may be having some interference with Susie Tucker. Can you put your phone on mute?
In my phone, I'm actually using my computer.
Okay, actually.
It's been me, I don't know. Now here is still symboling because it selected the last attribute here by default, right? So some of you ask me what a class is. A class is a valid value of dependent variable. In which you have -3, -2, Z1, Z1 to 3, etc. So now, some algorithms, you have to have your, and we're going to hit it on week 5. For it's on non-discretized. By discretized, you might get more accurate results, and results are easy to interpret because tree is going to have less branches. So then the pick a similar data set, and I will already have it open after that. Alright, here, set, our data set, it comes with installation. So see, it shows me the pedal width, this size here, and here it shows me the class. So are is it other, or is it versus it other, or is it Virginia? Okay, I cannot pronounce this. Anyway, so based on the values here, we are trying to determine what iris it is. So iris is a class. And in this case, we happen to have 50 in each class. The set has 150 instances. So I'm going to go here and click on the Classify tab. So I'm going to go ahead and delete all of this. The results bar, delete. I'm going to show you from scratch and do here and delete. So this gives you different sections, right? So what percentage split, it's going to use the specified percentage here, training data. The remaining for the data. Training data is the data used to build the model. So here, with data, our class is known. Use this data we have over here to map it to the known class. After that, we're going to use our model we develop to predict the class a new instance. New. We're going to use the model to predict what class is going to fall into and compare if our prediction is correct. Right here, classify, and shows G28 algorithm. The algorithm is to build the decision tree, which is a bunch of if statements basically. Here is, let's look at the confidence after minimum number of objects. It tells that we can stop at when node has 2 instances falling into it. Now I'm going to go ahead and I'm going to click, well, not here, I'm going to show you more options. It told me what to include in the output. Put the model, this is actual structure. Now here is output statistical class. Output confusion matrix, prediction for visualization, and we can also select output predictions if you'd like. I'm going to click. And what is this is the last attribute by default. That attribute I'm going to use as a class. So is I have 5 attributes, and here is the number of total number of instances, 150 in the data set. Remember? Now the test options that I use is a textual representation of a tree. Showing me here, total width is 0.6, use one branch. If the total width is greater than 0.6, the second branch. So it could be difficult to follow. Good news are here. Click and say visualize tree. So what I'm going to say is here, total width is less than 0.6. This is the type of arrays that I have. I have 50 instances into that class. Let's another branch, and I'm saying if the total width is greater than 0.6, we're going to continue. The here is split further. And 1.7, it got this class done. It's going again, and it's saying if it's less than 1.7, further. And if it's less than 4.9, done. Again, if it's greater than 4.9, we do analysis. Over here tells you how many instances fall into each leaf node. Right? Leaf node basically is like a starting point. 3, 46, 3, and the second number is you how many fall ever. So number is omitted. It's accurate down here, right? So now, see, this maps to textual representation. Here, right? The next attribute to split attribute happens. Determine which attribute to split on. There are algorithms. If you look at the presentation, some are listed in there, like information gained in the index, is to choose a split point so that it remains to do down the tree, let's say this way. You need to know the details of each option, just an overview. So now, here it's giving you set. Right about 1/3 is for the test set, which is 51 in this case, so it's approximately 1/3. It's showing you that 14 instances in a test set have been classified correctly, and here incorrectly are details, the errors. This one here, it gives you the accuracy for each class. No rock area here is 1. It means the prediction, the classification for that class is perfect. The class 1, the better the model seems to be. Right. And in that example exercise, I went into detail for each of the statistics just to see here. Here shows you the weighted average for each class. Now, confusion matrix, it gives you the actual class and the predicted class. So here's that class, right? In class C that were classified correctly, and 2 went as B. So here, the dominance is classified instances. Everything outside the diagonal is not. Right? So we have another options, cross-validation. Faults. Basically what it means that the algorithm it's going to run 10 times. Each time, one tenth of the data will be used for test, right? Validation. So it's going to go ahead and use the same settings. Start. And now visualize 3 right here. Visualize 3. That some of you pointed out that the models used to look the same. It will use the same set of data to construct it, but the same is the confusion matrix and accuracy by class. So what I ask you to do in your homework assignment is to compare. And if you look in your book, part of the comparison is to compare error rates, how much time it took for each algorithm to run. You must compare the RAC area under the RAC curve. So basically how each class is predicted. So here we are still close to 1. Here. On the test set, remember? Confusion matrix is a little bit different, see? Now, what you can do also is use training set, so that's an hit start. No results could be a little more accurate. But the core of this, and I did not ask you to do it at this time, is what you can do here is you can supply the test set. It has to be the file with the same attribute names, okay? But different instances, different wires. And hit save here, and then you're gonna do open file, and you're gonna do, just assume that it's a different set, just for the sake of demo. Hit open. And what I'm going to do here is I'm going to right click and I'll say we evaluate current test set. So it's another way to test how good your model is. I did not ask you to do it in this exercise. But possibility rate. Okay. About different test options with the disease structure. So this ask me how do I decide which of my variables is dependent. Variable is the variable that you want to classify. There are many approaches. First of all, you really need to understand the purpose of your study. What trying to I have collected. Instead, there is more than one answer. I use my car data to predict the per gallon. I use car data to predict what the cost is, right? Classify. Classification algorithm determines into which is going to fall into. It's different from prediction. We are not predicting a value. We're going to see prediction later on, probably next week. We talked about that. Now, ask me, why do you choose algorithm, right? So that's basically what we're doing is we classify your instances based on of independent attributes. This is made based on the values of independent. Here it would make more sense because you've got more attributes. Example, right? So on season 3 here, I did this see. So this is showing me textual representation of the tree. Notice that first is the number of doors. Okay. Right, good. So base, right, and break. There are ways behind the scene that can be used to determine which attribute to use. Gain is one of the criteria. You don't need to understand, you don't need to know that formulas in detail, but what you know is a high level to interpret the results. Oh, that's a good example. Question mark. That means that you have enough instances of class 3. The algorithm did not work well to predict class -3 because rough area is a question mark. Most of the values are 1, but 0.5, it means that it did not work, right? The error is, they call it biased. So, yeah. We can visualize the tree here also, but here it will be a little bit hard to read because too many attributes to work with, let's say this way. So what I could do is I could maximize that, I could right click and to screen, it's a little bit easier, and then I can just zoom in particular branch. Happening at the particular branch and how it's doing its split and so on, right? So I'm going to close the window. Okay. And is a class. So what we also do is to develop a sparse model, we can delete some of the attributes. Some of the attributes we're working on, how to guide that, and going to post you the link for some videos. Here, select attributes. Here, it's using different algorithms to attributes would be more to your study. So, start. Let's see. So it's showing me for the symbol in attribute, we got 1, 3, and so on, perhaps. So what I could do is I could go ahead and let's say we leave 1, 3, and 7, remove the rest. Let's see here. Remove 2, 4, 5, 6, 9. That's playing around on your project probably. Okay. And we're going to go ahead and try it again. That's how it was doing. It will make number of doors in wheelbase, right? So that mostly it's using the best. Go ahead.
Tu peux venir là aussi si tu veux.
What's that? If you're not speaking, because we want to have a good quality recording, something we want to review later on, and the classmates who were not able to attend. So what we do is they're gonna go ahead and run it again. Cross validation. Start. Click here, and I'm going to say visualize. less branching here. And I'm gonna increase, do this, fit to screen. It's a little bit easier to read, right? But without compromising the other, let's say. So we really have to be careful when we decide which attributes to remove. Right or wrong answer. One way to approach the problem. Okay. You asked me earlier that I could describe what here based on the example that you have posted in the live project. Well, each problem has a different approach, right? Really compare one with the next. The solution you use depends on the data that you have. All right. So now go ahead and see who joined. I'm gonna stop sharing for a minute. So stop sharing. Let me see. Yeah. So I joined this. Right. So for you who have joined, I see Frank has a question. Frank, go ahead.
Well, yes. Thank you. Presentation. I had a question with regards to the process of selecting which attributes to keep. Now, with the J48 algorithm, you were going to the last attribute, and class in one example, the other example, the car's example, you had symboling. What makes you select? What makes you select that?
On my study, I just decided that I want to determine what symbol and category my car is going to fall into and other characteristics. But there's no right or wrong. I can decide to predict the miles per gallon range based on the other characteristics of the car. I try to go with the cost. With the quiz, there is no right or wrong. It depends on the studies that you want to do.
So the decision would have been if you selected right, you would just look at how accurate the prediction percent is to decide whether or not you would stick with that as a selection.
If I selected the price, I see how accurate it classifies to the rest of the price. We can go ahead and do that if you like. Share desktop. Okay. So I'm sharing my desktop again, and I'm gonna go ahead right here and
okay.
Right. So I'm gonna create price and I'm gonna undo. All my back again. The price over here.
Okay.
Now price is gonna be a class. We determine price is gonna be below 8 rate, or it is gonna fall in the middle range. If price is gonna be above 1352.5, right? So we set price. We have the data set. We have set of what other attributes, and we map to the cells. I'm going to classify. Okay, change that too. It didn't change it for me. I'm gonna price. Right. Let's just use the cross validation. And I'm going ahead and I'm gonna click start button. Start. Show me different. It's splitting on A attribute, splitting on the length, and it's going on the city, miles per gallon, and so on. Let's visualize the tree. All right. visualize the tree. You can go ahead and a little bit more readable. So I'll say here, if AP is less than 83, then is going to fall into this range, below 8303.5, right? And Michael classified two instances into that price range. Same were classified in error. I'm going to say, what if our price range is between 83 to 13? 13 is a square bracket, so that means it's inclusive, right? If this is the case, we don't have information. We're going to need to look at the balance. Now, go ahead here and say, what if balance is less than 168.95? Then here you got the price going to fall into this range right here. Right? Another range for links. This is yes. Right here is a little bit more complicated because we have to look at city miles per gallon, or looked in this case. City miles per gallon, we're making a decision here. So notice that if you fall between 22.5 and 27.5, we don't have information, it's looking at the height. See, the structure is different. We chose different attribute to use, right? Yeah. I think that's going to help you is that we select a data set. Notice that it has a description that goes with it. And description, it tells you what attribute gets most selected, let's say. So for that, most students do the price or the miles per gallon. That's the most selected one. But simply you can still do in the lanes, right? So it's kind of telling me which attributes are important, so to speak. It uses the information gain algorithm by the same to predict. I hope I answered your question, right? Ooh, what did I do? No problem, I figured out. Okay. Let's see if else is here. Any questions? So I can yes.
Elena?
Yes, I can hear you, yes.
I have a question regarding the assignment here. Okay, announcing the results. Do we list all three options or just pick up one option and work with it?
Well, basically what I want you to do is I want you to compare the results, right?
Mm-hmm.
Which do you think is going to be right? Which one is accurate results? And yes, choose one of them and discuss what do you get. What do you basically, right? They're wrong, but I'm looking at your understanding of the topic, right?
Okay. So you're looking at the visualization of results. You want to see three of them, right?
Yeah. No, just explain.
What would be good enough? Okay. Thank you.
And one thing that I've noticed here is that, first of all, it's a group exercise, right? And it's challenging. I understand that everybody has different work schedules. And I understand that I was a student also, so it sounds similar. But what's to happen is you need to come up with decision as a group on what data set to work on and which variable you're predicting, right?
Yeah, we got that.
Yes, it's a decision, so that needs to be done as a group. So
Yeah.
and the case of that, yeah. So, the question, anything else we can work on?
Very good, Professor. Thank you so much.
Are you going to post a recording of this conference if you're?
Yeah, I'm gonna pause the recording. Sure. Sure. Mm.
Hello? Oh, no question with the student, or they just listen? Okay. I will let you know.